very good morning to all of you. This is Mineev Goswami welcoming you all in a live and interactive session which you're watching at PM eVidya channel number 6 to 12 and of course on our official YouTube channels which are NCERT Official and NCERT PM eVidya class 6 to 12. This is our virtual lab session as it's 10 AM in the clock, and today we are going to take up class 9th subject science, and the topic that we are going to take up is demonstration of simulation to show gases are readily compressible and liquids are not. But before that, I just want to introduce what are virtual labs. So a virtual lab is an online platform that simulates a real world environment. It lets students and researchers conduct experiments and perform procedures on a computer or any other portable device without needing a physical equipment or a dedicated lab space. Some of the key features are that you can practice without any risk, assess expensive equipment, and of course learn from anywhere. So these are some of the perks of virtual labs, and to elaborate what virtual labs are in real and to give us a more elaboration on the topic that I have already discussed with you, I'm having as an expert in the studio Dr. Anjana Bhardwaj, who is an academic consultant at CIET NCERT New Delhi. Ma'am, a very warm welcome.
Thank you.
Okay, so before we begin this session with Anjana ma'am, here I want to introduce our sign language interpreter as well, who is Savri. Savri, a very warm welcome to this 10 AM virtual lab session of science for class 9th. But before that, I just want to share a very important information with all our viewers, and that is if you have any question regarding the session, you can directly ask us via calling us on our phone number which is flashing on your screen, and that is 8800440559. With that, if you want to send us any feedback, any suggestion, you can directly write us on our mail ID which is diksha.training@ciet.nic.in. Same one is flashing in the form of ticker on your screen. And as I mentioned our YouTube channels at the beginning, I just want to tell you that the live chat box facility is available there. So if you're watching us via our YouTube channels, you can ask your questions through that as well. Okay, so now it's time to start this important and very interesting session with our expert Anjana ma'am. Ma'am, the first thing that I want to ask you, that when it comes to the chemistry subject, okay, so what is the importance of these virtual labs?
In terms of chemistry, we can say
yes.
that. Yes, virtual labs are very important in reference of chemistry because they provide the important that platform where we can, or users or students or teachers can access virtual labs in a very safe and guided manner. In real laboratories, performing the experiment of chemistries is sometimes be risky, hazardous, because it involves the reactions, chemicals, heat, and also it cannot provide to repeat the experiment at number of times. But virtual labs provide that platform that student can perform any experiment, any step, or in fact self-evaluate them in a safe guided manner. Also virtual lab can provide that platform also that where physical labs or real labs are not easily accessible to the rural areas, or we can say that instrumentations or sometimes the experiments where it's not easily available to all the students. In that area also, teachers and for students, it's very convenient to experience real lab like experiment in virtual labs platform. So yes, we can say that virtual labs are very important in terms of chemistry.
Absolutely. In one word, I just want to say that this is revolutionary.
Yeah.
Ma'am, but before that, I just want to discuss that today's experiment is all about, and the topic that we have picked is demonstration of simulation to show gases are readily compressible and liquids are not. But before that, I just want to tell you, or I would like to highlight the things that what we are going to discuss in today's session and what we are going to learn from here only.
Yes, in today's demonstration, we are going to learn about the importance of matter, and topic of today's demonstration is of grade 9th. Gases are readily compressible while liquids are not. So we can see in today's demonstration that when we apply the pressure on gases, then the volume decreases easily, but when we apply the pressure on liquids, then the volume does not decreases. We can say that in terms of intermolecular spaces, in the gases, intermolecular spaces are very large. So when we apply the pressure, that intermolecular spaces get reduced and also volume get decreases. But in liquids, when we apply the pressure, the intermolecular spaces are already very close to each other. The space is very less. So we can say that when we apply the pressure, liquid's volume does not get decreases. So we can see how when apply the pressure in syringe with oil, with water and with air, how the intermolecular spaces work. And it will be easily differentiated that the gases will be readily compressible while liquids are not.
Absolutely, we'll just going to perform all of this later in the session. But before that, ma'am, as I've already mentioned the perks of virtual labs, what these virtual labs can do, and this is revolutionary, as we have already spoke about that in rural areas, this is kind of a thing that people can access like from anywhere, anytime, and it's absolutely safe. But I just want to tell you that where we can find these virtual labs, and is this open for all, or are they free of cost, or is just some kind of a expense is actually involved in it?
No, it's totally free of cost. We just have to sign only once with our Gmail ID. After that, we do not need any procedure to follow up, and only the Wi-Fi is required for to access the virtual labs. Except that there is no other things will be required to access all these virtual labs. I'll show you on the screen that how to access these virtual labs. First, we have to write www.diksha.gov.in, and it will lend to the page of Diksha. When we scroll down under the focus areas of Diksha, here focus areas of Diksha, we will select the virtual labs. It will lend to the page of virtual labs. Here about the virtual labs, laboratory work is pivotal not only for teaching learning of science and maths, but also helpful in different subjects like social science, language, vocational skills. And according to NEP envisions development of digital repository of content including coursework, games, simulation, AR and VR with a clear public system for rating by users on their effectiveness and quality. These e-resources help students in visualizing the concepts in a better manner. Now here we can see virtual labs e-content, and these are available from grade 6 to grade 12th. So today's topic is of grade 9th, so we can select Explore. Under Explore, I'll select English medium. You can select Hindi medium also if you want to explore the content in Hindi. And today's topic of demonstration is of science, so here I'll select science. Now this will lend to this page, welcome to Diksha login page. So I will log in, sign in with Google. I'll select my ID and continue. Now the grade 9th, in the right side, all the topics of grade 9th virtual labs are here. Today's topic is of gases are readily compressible and liquids are not. So I will select this topic. Under this topic there are 3 panels: experiment PDF, explanation resources and learning resources. In experiment PDF is the PDF of the experiment. Under explanation resources are the theory of this topic, then procedure of real laboratories as well as of simulatory, then video, animation and the resources file from where these data have been taken. And at the end, under the learning resources are simulation and self-evaluation. First we will go to the theory, because before performing in simulation labs or in real labs, theory understanding is must. So objective of the topic is to understand that gases are readily compressible and liquids are not. Theory: everything in this universe is made up of material which scientists have termed as matter. So this is the important phenomena, matter. Here we will discuss about the matters. Matter is defined as anything that has mass and occupies space. Matter is defined as mass and occupies space, and we can say that there are 3 matters: solid, liquid and gas. And here we will discuss about liquids and gases. Everything we can see here, touch, taste and smell is matter. It is made up of tiny particles that cannot be seen with the naked eye. Air and water, gold and silver, table and chair, these are some of the examples of matter because they occupy space as well as have mass. Now, characteristics of matter. Particles are the building blocks of all matter. Particles are the main building blocks of all matter which form the matters. These particles have intermolecular spaces between them and attract each other with a force and are in continuous random motion. All material bodies occupy space and all material bodies have weight and have mass, therefore refers to the matter. And based on their physical properties, matter is defined as, or we can say that classified as, solids, liquids and gases. Solids have a strong molecular force as well as definite shape and size. Therefore, solids are unable to flow or compress because the intermolecular space in between the solid is very tight. In liquids, have large intermolecular spaces and weak intermolecular flow. Therefore, liquids have no definite shape but can flow and therefore are not compressible. Whereas gases have low intermolecular flow and high compressibility because have high intermolecular space. So, states of matter, the solid state as we can already discuss that have definite shape, fixed volume, have no compressibility and tend to maintain their shape. Intermolecular space are tightly packed together with strong intermolecular force, and these intermolecular spaces are very less as compared to liquids and gases. And compressibility, if we talk in terms of compressibility, solids are incompressible as their volume cannot be decreased if we apply the external pressure. But in liquid states, adapt the shape of their container when apply the pressure. Both solids and liquids can diffuse into liquid with atmospheric gases like oxygen and carbon dioxide dissolving in water. That is crucial for survival of aquatic life. When we talk about intermolecular space, the particles are close together but have more freedom of movement as compared to solids. So, we can say that intermolecular spaces are larger than those in solids but less than gases. And compressibility, liquids are considered incompressible compared to gases because they cannot decrease the volume when we apply the pressure. Last is the gaseous state. Intermolecular space, we can say that gases have large intermolecular spaces as the particles are far apart and move very freely. So, the intermolecular forces are very negligible, and when we talk in terms of compressibility, gases are highly compressible because of the high spaces present in between the particle. Changes in pressure can cause substantial changes in the volume of a gas, which states that volume of a given amount of gas is inversely proportional to its pressure when temperature remains constant. This is the diagram of arrangement of molecules in solid, liquid and gas. We can see from the diagram that intermolecular space is very less in solids because the molecules are tightly packed. Now, in the liquids, intermolecular space is more as compared to the solid but very less as compared to the liquid gas. And at the last, in the gases, intermolecular space is very high. So, this is the main reason the gases are readily compressible when we apply the external pressure. Now, the learning outcomes, students can learn about the matter and states of matter and also can be able to understand the compressibility of states of matter. After this, we will talk about the procedure options where we have under this topic in explanation resources.
So now
Pro-
we are going towards the demonstration.
Yes.
Okay.
But before that, we will read the simulator procedure.
Okay.
First, in the simulation, an introductory note is shown. Then we will follow these steps, and then the simulation will be finished. After that, we will observe what happened, and then results in discussion part. So now, if any student or learner want to perform simulation, before simulation want to go through the videos or any animation, then it will be available under the explanation resources. Here the video, here the animation.
Okay.
Now we will move forward to the simulation. We can say that demonstration part. You can maximize also to the full screen. Now this is the demonstration part. First, here is the term compressibility refers to the amount that a given volume of a substance, whether solid, liquid or gas, decreases when subjected to pressure. The degree of compressibility depends upon the intermolecular spacing between the particles of a matter. The greater the space between the particles, greater the possibility of the particle being compressed. So we will do the next option. Click on the syringe and drag it to the water.
Okay.
Pull on to the piston. Now in syringe, water get filled up to the mark. See here. Now the pressure is being applied by external piston, but we will see that it will not compressed. It will remain constant to that level, 10.
Got it.
Now we will select under the panel oil. Click on the syringe, drag it to the oil. Now click on the piston. Syringe will take up the oil and it will showing that mark up to 10. Now we will apply the pressure, and after being applied the pressure, the volume is again at the same level. So
Okay.
it shows that liquid did not compressed. Now in this panel we will select air. Now click on the syringe and on the piston, air is being taken into the syringe and the mark is up to 10. Now we will apply the pressure and see how gas can compressed in the syringe, and it get to the mark below than 10 up to 5. So here we can see that air can easily compressed or gas can easily compressed, but liquids not. The intermolecular space between gas particles is much larger than the intermolecular space between liquid particles, hence gases are more compressible. This is the simulation, or we can say the demonstration of this topic. Now if student want to self-evaluate themselves that what they can learn in this experiment, they can self-evaluate also. Under the learning resources is the self-evaluation. Here are the questions available to assess themselves, and after that they can also get mark them. These are some of the questions. Which one of the following statement is true for liquids? Liquids have high compressibility, have a definite volume, have a definite shape and exhibit strong so the topic is liquids have high liquids have
definite volume.
Yes. So if we click on the correct answer, it will show with green, and if we click on the wrong answer, it will show that this is the wrong one and the correct one is in green.
Okay.
Which of the following is highly compressible? See here,
Gases.
then it's showing correct. So this is how you can self-evaluate them yourself. Now I am clicking randomly on any answer to just show that there are some questions here in the self-evaluation. Gases have definite shape and no definite volume, definite shape and definite volume and no definite shape, no definite shape and no definite volume.
Option 4.
So yes, correct. Gases have no definite shape. Which of the following is an example of solid state? Hydrogen, argon, oil and ice. So ice is the example of
Ice.
solid. Yes. Which of the following is a strong intermolecular force of attraction between particles?
Solid.
Yes, correct. Now, which of the following is not a characteristic of gas? Exerts pressure equally in all directions, volume is not fixed, it has a low density, or it has a low compressibility.
It has low compressibility.
Correct. So this is how we can evaluate ourselves. The decreasing order of compressibility in of states of matter is decreasing order gas, liquid and the solid, because gases are highly readily compressible and solids are not. The gases are highly compressible because the molecular force of attraction is very weak, the separation between molecules is large, molecules move randomly and the separating force is strong. So, the molecular force of attraction is very weak, is the wrong, and the separation between molecules are large is the right one.
Yes.
The experiment, what happens in volume of air in the syringe, air gets compressed. So, we can also retry them, or we can see the solution if we want to see. So, this is how we can self-evaluate ourselves. So, this is the demonstration of class 9th. Gases are readily compressible while liquids are not.
Ma'am, but I just want to know, beside this, what do we have, like any other study material which is providing on this Diksha portal, or it's just something like this only, where we have the procedure, the theory part, self-assessment, and of course the simulation part, or is there anything else as well?
Yes, you can also explore the under explanation resources are theory, procedure, video, animation.
Okay.
You can explore video and animation also here. See, these are the animations.
Okay.
Yes, before performing the experiment in real labs or in simulation, you
So
can.
this actually gives you an idea of a simulation.
Yes, correct. Ki how simulation can be performed and how you can perform the experiment in real labs.
Okay.
So these are the other resources as well, and the video is also there. Video gives you the outlook of real labs.
Do we have some other links of study materials?
Yes, you can explore under the resources panel.
Okay.
In resources, there are other websites and books. Which
Those are recommended.
Yes.
Okay, got it.
Yes, we can refer these websites also, because all these material have been taken from these websites and books.
Okay, ma'am, but before we wrapping up this session, I just want to ask you one very important question, that what is the significance or a real life example of the demonstration that we just did it on virtual labs?
Yes, this is a very important experiment actually. The LPG, CNG gases are compressed in a very small containers which we used in our homes. Also the oxygen which is used in the hospitals are compressed in small containers, and because these are the gases, so they can be compressed in a very small containers up to their volume. And also when balloon filled with air, when we compress the balloon, air get passed out, it get compressed. So this is also the real life example of this experiment. And yes, bottle filled with water, we did not be able to compress it, and it does not get decreases in the volume. So these are some examples which depicts this experiment and tells that how the gases are readily compressible while liquids are not.
Anjana ma'am, you are yourself an academic consultant, so
Right.
this would be perfect question for you to be asked. Like, what do you think is it important for teachers, and how does it help them?
Yes, virtual labs are also very important for teachers, as virtual labs helps teachers to innovate their experiments or their demonstration or their lectures which they provide to the students, and it easily help them to make students understand that complex concepts in a very easy or self-guided manner. The virtual labs provide the platform where user can perform the experiment in a step-by-step step. So it helps teachers to understand or make students easily learn the complex concepts in a very easy manner. Also make their demonstrations very innovative and self-learning. So it also helpful for the teachers as well.
Okay, but ma'am, any conclusive remark from your side on this session?
Yes, virtual labs are not the replacement of the physical laboratories. They are just providing additional support to the real laboratories, where it bridge the gap in between the theory and practical, where students can perform any experiment before performing in the real labs. So these are not the replacement, these are the just additional support to the real labs.
Absolutely, this is not a replacement, but rarely where you can see your chemistry labs, physics labs and the other labs in your school. Here on virtual labs, you can actually perform those experiments without any delay or without any tension, because this is absolutely free of cost. And of course, this is this is convenient for everyone who are watching this session, and of course the students of class 9. Thank you so much, ma'am, for this insightful session.
Thank you.
And for coming here in the studio and elaborate this, and you actually performed the whole experiment on virtual labs. Thank you so much, ma'am, once
Thank you.
again. Okay, I just want to thank our sign language interpreter Savri as well, who has joined us throughout this session. Thank you so much, Savri. But before we wrap up this session, I just want to tell you what do we have for you on this entire day on NCERT Official. Let's take a look via schedule. After this, at 12 p.m. we'll have class 3rd English session, and the topic that we're going to cover is Badal and Moti. At 2 p.m. we'll have class 1st Mathematics. The topic is what is long, what is round. At 2:30 p.m. we'll take up class 1st subject Hindi. The topic is Khatre Mein Saap. At 3 p.m. we'll have class 2nd English, and the topic is We Are All Indians Part 2. At 3:30 p.m. we'll take up class 2nd Mathematics, and the topic that we're going to cover is Which Season Is It Part 1. 4 to 5 p.m. this is our 1-hour online training program where we are going to discuss about online course, concept, need and scope, and we are going to wrap up our session at 5 p.m. with our Sahyog session. The topic that we are going to discuss is positive sleep habits for enhancing memory for students. That's all for today's in virtual lab. Tomorrow we'll have virtual lab session as well at 10 a.m. sharp. So don't forget to join us again on NCERT Official. But it's me, Neef Goswami, signing off for now. All you need to take care of yourself. Thank you so much for joining once again. Thank you once again. Namaskar.